My talk is going to be about basically S3. I've been working a lot in this space in local stack. And the goal of this would be to show how you can leverage our implementation to help you develop locally and speed up your development. So we could basically start by talking about what even is S3. I believe most of you must know it if you've worked with AWS. It's means simple storage service, and it's basically an object storage service with an HTTP API. It doesn't really get simpler than that, but it's still not always easy to work with. But luckily for us, it's used everywhere, I would say. And it made its API standard. Like a lot of other cloud provider have been using the S3 API to make their tool compatible with all of our external toolings, like Cloudflare R2, I think the Azure Blob Storage as well. And it's also an old service. It was the second AWS service that was made public by AWS. It was in 2006, so it's almost 20 years old now, and it shows in some parts. It's been followed by EC2 in 2026 as well. And SQS was actually the first service made public by AWS in 2004. They both use XML API, and yeah, it kind of shows their age sometimes, and there is a small quirks that we have to work with in local stack as well. We could quickly talk about S3 scale. There is this quote from a VP and distinguished engineer at S3 that they have tens of thousands of customers with S3 bucket that are spread across millions of drive. So the scale of S3, I would say, is it's not something we can visualize easily. They have like a fleet of millions of hard drive, which I don't think it's easy to imagine. They process 100 million requests per second, 400 terabits per second. They store 280 trillion objects. That seems very massive. And they also, for object integrity, have 4 billion checks on competition per second. So all of this scale is it's absolutely insane. It's a very great product still. I love S3 myself. It's very easy to work with, and I like it. It's just some quirks. So in local stack, we integrated S3 a long time ago now in 2017. And luckily for us, we don't care about S3 hardest problem, right? It's just like the hardest part of S3 is the fact that it's distributed. It's the resiliency, the durability. They guarantee 11.9 of durability. So you should never lose anything you put in S3. But all of this is not really important for us, right? The goal for us is to focus on the API, the fact that it works, but the fact that it's durable is not really a big part of it because it's a testing tool. The first commit in local stack was in April, and the first implementation was actually adding S3 bucket notification. It was a commit made by Valdemar, and it was adding inter-service interaction. Basically, it was our S3 implementation was based on a third-party library that is called Moto, and was mostly providing mocking tool for AWS in Python. And this is all great, and it's a very great tool. It already provides a lot for S3, but over the years, since 2017, we've been basically building on top of it to provide more integration with our services like Lambda, for example, this notification that would trigger Lambda in local stack, and that would do some over processing on top of it. So this was basically it until 2022, where in 2022 we started moving more of this implementation inside local stack itself and actually putting it into our new framework that is called ASF. That is mostly a framework about parsing and serializing requests and allows us to be very efficient in the way we follow like new AWS features and things like this. So we've started in 2023. We decided to do a full rewrite of S3 where I spearheaded the change. And the goal of it was to focus on parity and API contracts. S3 it's a big surface. There's like more than 100 API operation. The core of it is very simple. It's basically you put an object, you get an object. You can also create some multi-parts, but small parts of object together, and then you will merge it into this one bigger object in the end, and it's a bit more efficient. But all of this, there is a lot of, let's say, operation that you can add on them, metadata. You can configure your bucket to do specific things like encryption, replication, notification. You can make a bucket actually be a website and expose the content of your bucket as just a regular website, for example. And we needed to push further on parity. So the decision was made to move the implementation fully in local stack with no dependencies and start the rewrite. So the dream of every software engineer, basically. It's if it's not our code, it's not as good, right? So, and for this, one of the big part was just writing a lot of tests. We in local stack we have this framework in place where we can run our test against AWS and save the result, and then run the test against local stack and verify that our results are actually the same. And this is very important to ensure parity. We have more than 300 tests for S3 that are AWS validated. It's the most validated service, basically the one that has the most tests, because it's also one of the most used in local stack. Sadly, there was a lot of edge cases to handle because S3 is a bit specific, and also the way we have our framework is based on the specs that are shared, that are open sourced by AWS. Those specs basically define what are the input parameters for some operation, what are the output parameters, and how do we map all of those. And sadly for S3 in Python, they're actually not complete. They are missing some parts. Basically, S3 will return a response from you, and the Python client will actually not serialize everything out. So one example I have is basically if you delete an object in a version bucket in S3, S3 will return a header that indicates if that object was actually a delete marker or not. It's a specific case, but Boto, the Python client, will not serialize this exception. So we'll have to go through the raw headers of the response to actually get it, which makes us not possible to actually serialize this header as well. So we had to actually patch the specs only for S3. And also, for example, exception, like the exception were just default exception returned by the client, and they were not properly serialized with all the fields that were missing. So we had to actually create those exceptions from the specs. And S3 is the only service where we're doing this. There's a lot of small difference in the service and in the serializer in S3, which I think is a witness of the fact that it's almost 20 years old, and AWS is very keen on keeping backward compatibility. So they have sometimes to do some concession and not always like do some weird things that they can't really get out of. And this rewrite lasted for the full rewrite basically took maybe 2 to 3 months, but most of the work was done in one, and it gave very good results. It allowed us to have streaming support. So beforehand, we had to load the full object in memory before storing it, which was very not efficient. And it really reduced the memory usage of local stack when you would be putting and getting a lot of objects. And as a side effect, we had a speed and throughput increase between 10 and 30% for almost put and get operation. And it can be up to 16 times faster for list operation. And we have way better parity for list operation and pagination also. We have better exception and validation done, like the validation. Our goal in local stack is that if you do something that AWS wouldn't allow, you shouldn't be allowed to do it in local stack either. It should raise the exception so you don't have the case where you create your application, it works with local stack, and you deploy in AWS and then it fails. I think that's not really good user experience, and this is something we've put a lot of effort into making it better. Also, better bucket versioning support. The support before was a bit clunky at times, so we try to put a bit more focus in this. And yeah, like I said earlier, better parity overall. Like there is more than a quarter of our test that only works for the new implementation and not the legacy one that is still available with a feature flag. So like we really pushed the parity way further. And also one really good part of this is that we have a massive increase, not increase, smaller actually time to fix. Nowadays, the fix are often shipped the same day as the issue is reported in GitHub, because we have control over all of the code where S3 is located. Beforehand, we had to do fixing upstream libraries, and then the time that is shipped, then we integrate it into our image, and those fixes would take 1 to 2 weeks. So now we have a lot of good. It kind of confirmed that this was something we needed to do for one of our most used service. And I think now, after all of these talks, we could maybe go over a small demo into showing how you can actually use LocalStack and S3 to test your local application. And basically, you can now, yes, we'll show how to test this. So how to test this application. Sorry. I would like to basically show InfluxDB. They've been doing a big rewrite. I don't know if some of you are familiar with it. It's this time series database that have decided to do a big rewrite in Rust in, I think, 2021. And they decided to use open source technologies also. And most the biggest is the Apache ecosystem, the Arrow ecosystem, and Data Fusion, to be able to nicely extend with other third parties. And this rewrite has been going on for, I think, almost 2 years now. And they already have it in online for their cloud development, but they have this open source repo that you can build yourself, that you can build a Docker image from. And the big change with this new database is that they are splitting, like a lot of new products today, the compute layer from the storage layer. And they have all of this basically compute layer that is in their open source repo. That's what they're providing, which is all of this part. And they are building this on top of Object Store, S3, GCP, Azure, you name them. And right now we're interested in the Object Store part, right? S3. So what we could show in this demo is that you can actually build this image yourself and make it work with LocalStack S3 to get like faster feedback and actually understand what the image is doing. We could imagine I'm a InfluxDB contributor and I would like to start contributing to the repo, but I don't want to start an AWS account, so I could quickly give it a try. So this is the repo of InfluxDB. I've done this Docker Compose, where we basically have the LocalStack image. We use the latest. We will have the InfluxDB image that I've built myself from the repo. And we also have another third-party tool that works with S3, which is FileStash. It provides a nice UI on top of multiple backends like FTP, S3, and some others. So what we could start with is starting the Docker Compose. Let's see that everything is properly created. You can go back to here. There is this specific health check here because I think InfluxDB is still heavily in development, and when the object store is not available right now, it tends to crash. So this is not really great. So I have to we're using this nice initialization hook from LocalStack. It allows you to provide some bash script that will create some state once you start LocalStack. So in that case, I'm just creating a S3 bucket, and then we just wait that this S3 bucket is ready before actually starting InfluxDB. I had to dig through the code to understand exactly how to start it with S3 as a backend and set some configuration file because it would dump the state. It has this kind of buffer where you will only get the data into it will keep everything in memory when you write to it, and then it will dump it into S3 around 30 minutes later. We will try to make it faster, so to not make this last very long. So let's go back to the logs. Everything is created. We can follow the log of LocalStack, the logs of InfluxDB, and the log of FileStash. Basically, we can see here that it's nicely initialized. It uses the endpoint of LocalStack. It's connected to LocalStack. And here we can see from the very verbose log that we had the health check. The init script here was creating nicely the bucket. And also we can see some requests around here that are actually done by InfluxDB already. So we can properly see that they're properly created. from, I would say, the user agent here, object store, which is the library that InfluxDB uses under the hood to communicate with S3. Yes, so we could go on and configure file stash. This is normally there should be no logging, but an admin settings. Yes, we could just create a random admin password, and we're gonna go configure it to listen to S3. Let's go and delete all the backends and just configure it with S3. We won't put any authentication middleware, and we'll just go over the settings. I think there should be more settings than this, if I remember well, but I can't. This is the demo effect. Normally, I should be able to have more configuration. Interesting. That is not great. No, yeah, that's this. Correct. Yeah. That is not great. Well, in the worst case, we can skip that part, but we were supposed to be able to configure S3, but it doesn't seem like this is possible right now. Okay, well, too bad. Maybe, yeah. Yes, maybe. Yeah, no, I can. The demo effects that worked the last time I've tried it, but we can just skip that part, I would say. That was supposed to be another settings. Anyway, that's okay. We can just do regular comments. So we can just do a regular comment over AWS local S3 and do some ls, and we can see our buckets, and then we can go into and see the different files. InfluxDB started creating some files. There is already the segment, and if we go here, we can see they've created some metadata file. Yes, this kind of threw me off a little, but that's all right. We're gonna bash into the InfluxDB container and see the data. Let's go over here. So we've been, we can go back to the here. We've been mounting a file here to actually see data into the InfluxDB database. We are bashing into the container because they have a nice CLI that allows to actually query and write the data without creating a client from external, like language or anything. It's going to be much easier this way. So we could basically, we can see that InfluxDB created it. We can go look at the logs. It said that it created a new database. It inserted and some data in there. And in local stack, we can see that it didn't do anything yet because it takes time to dump the data there. So what would have been nice would have been to actually look into the file stash, which I don't understand why it doesn't work, but that's all right. And yes, now we could actually query the data. We can see that it's in memory for now. Okay. Missing fields. Yeah. So we can see some data is in the database. We can look at the logs. It returns. That's all right. Everything is fine. The data is in memory. And here, it seems there was some put object done by InfluxDB. So now we could again maybe go look into how it created data, and now we can see a DB field. And it created the table. It's the table name we've been creating. When we inserted the data, we've been creating under the full name, and now we can see it exists in local stack. And we can see how also we created some, it has some basically index that is called CPU. And we can see this and then create it, and it's just a Parquet file. And we could actually inspect this Parquet file to see what the InfluxDB has saved into S3. And yep, we can look at it. There's a lot of data, and this is a nice extension from VS Code that actually uses DuckDB under the hood that allows you to visualize Parquet files directly from there. So we can see the data is there, it's in Parquet, and we could actually query the data again from here. And again, the same mistake. Now we still get the same data, but now it actually does some requests to local stack, the get object with some 206, which indicates a range request because Parquet files are very efficient. You can only query parts of them. And here we could see just query the bytes from the 4 to 971, which is way more efficient to query like only parts of the file. You don't have to download the full file to get the data you need. So that's all the architecture around what they created. So yeah, I guess that kind of shows it. It's missing a big part of the demo, but I guess that's a demo effect. I will look into it and try to maybe create a repo to make this all easier. You could try it yourself again. Yes. Yes. So to finish up and wrap up this, there is also something I would like to talk about is that thanks to this rewrite, we've been enabled to actually create a local stack S3 only image. This is a slimmed down version of the local stack Docker image. It's only 100 megabytes in contrary, I think, to local stack, which must be around 400. It only contains S3. We removed all over dependencies, and this makes the image a bit slimmer. It's nice in CI to use it, and also locally if you really only use S3. And it's also spearheading local stack performance improvements. We've been working for this for a while now, and it's been made default into the S3 image with improved concurrency, and we have between 2 and 3 times more throughput with this S3 image. So I would encourage you to try it. There is a specific tag for it, and we could share it later on. And as a summary to this, I would say that the rewrite and everything shows that for S3, parity is paramount to us. We really want to be the best tool there is to actually test your code before deploying to S3, to the real S3. And we've been prepping a blog post around comparison about other S3 local tool that exist on the market, like S3 mock, for example. And we have some preliminary result that parity-wise, we're handling way more edge cases. And local stack allows you to develop locally with ease. And it could be for your new SaaS product. And you could use local stack locally to just develop quicker and understand why you would have some issues, but also for a fully fledged database like we've just seen with InfluxDB. I know for a fact that the underlying library they use for InfluxDB is using local stack in CI also and locally to actually do their test and having like better feedback. So this kind of shows the level of parity we've had. They also raised some edge cases for us that we quickly fixed. We have like a good relationship with them. So it's pretty interesting to see this kind of usage. I think Google also uses local stack in CI for Tensor Store, Tensor Store database. So it feels pretty nice. And also, yeah, our goal is if it works in local stack, it works on AWS and vice versa. And don't forget about the new Docker image that is free only. Thanks.
That was awesome. Thanks a lot, Ben, for just walking us through the whole S3 enhancements that you have been working on for the past year or so. I guess we do have a few questions coming up. The one that almost made me laugh was, can we now use DockerStack S3 for production?
Well, if you're not scared of losing your data, I guess that's fine. But I guess we would say that it's not really... we would not really say that it's a good use case for this. Mm-hmm. It's all right for your small, like local development, I would say, and trying it in CI. But for production case, I think we're still not really there. Also, we don't have really good you can only have one instance of local stack, right, for S3. So this is a bit of a, and that's not really where our goal is.
Definitely, yeah. I guess the second question is pretty interesting. Is would we see other AWS specific images like SQS, for example?
I think that's in the plans. We're looking into this. This S3 image was also like a nice showcase that we can actually do it, and we've been working towards this. So I would say the SQS one is normally possible. We don't have it. The implementation of SQS is also fully contained into local stack. So we would have ways to provide this kind of same slimmed down image for SQS. That's part of the roadmap, I would say, but I can't give a specific ETA about this.
And if I'm not wrong, SQS is also almost zero dependency, local stack native. So
yeah, the implementation is fully in local stack, yes, and fully
definitely.
in Python.
I guess we have the third question that is almost similar to what you mentioned at the end. Is like, how is local stack comparing against other S3 mocks?
I think we'll see more about this in the blog post that is going to come out, I would say, in the few next days or next week, maybe. And I would say it's pretty good. We are, I would say, better. Not wanting to toot my own horn, but it's just that our focus is parity. And S3 mocks, the S3 mocks from Adobe is not supporting as much. There's also, they don't support, for example, virtual host based buckets, and they have like big limitation. And often another one that's coming often is Min.io, right? And it's the same. Their use case is production ready. They are for production, and their goal is to be compatible with as many external tools there is. But do they want to handle every edge cases that AWS does? I doubt it. That's not really where they want to put their focus right now. So I would say if you deploy your code in AWS and you want to test it, better use local stack than Min.io for that, because that's what we are for, and that's not really what they are putting their focus on.
Awesome. That was perfect. And I guess just a last message of gratitude. Like, been using local stack S3 for 5 years. Thanks for all the work. And I guess
Awesome.
Thanks to all the community members who took a lot of time in kind of reporting us like bug reports, feedbacks, and a lot of areas where we could improve in, because the reason why we are here is because of the entire community out together. So yeah, thanks to our community for helping us out with a lot of these things.
Definitely. I am very grateful for all the bug reports. Like, I'm just happy to wake up with a bug report on S3, because it just means we're just further closer to parity. Thanks.
Yeah. And I cannot stress like how many people have actually said thank you for fixing because of you fixing their bug reports in a record time. So yeah, thanks for all your hard work on this as well. But with that said, I guess we are at an end for today's meetup. So thank you everyone who joined across all the different platforms, and thanks for staying with us, hearing from us all about the recent developments on the Snowflake and the S3 emulation. And we are so much grateful to have you for these regular monthly meetups. So yeah, if you are new to the local stack community events, just join our meetup community right over there, and just stay updated with all of the future meetups that we would be organizing. With that said, I hope have a great rest of the day, and we will all see you in the next meetup that will be coming up pretty soon. So yeah, have a good day, folks. Bye.